Okay, so for the last topic of the week, here are the big ideas. Okay, so we looked yesterday at factors that affect climate change and how it naturally happens. Okay, today we're going to look at why it might happen for human caused reasons. Okay, so why are scientists concerned about the current changes in our climate? Okay, what kind of climate trend would the Earth be heading into if not for our human influence? And what do scientists agree is the cause of the current changes in our climate? Okay, so here's the question you might have had as we're looking at the natural causes of climate change yesterday. Okay, now when I say climate change, I'm not talking about the one we're going through. I'm talking about the one that has happened over millions of years in the Earth, right? But currently, now, when we say climate change, we're talking about this current period of rapid change in our climate that we're seeing. Okay, so the question here is, if the Earth's climate has always been changing, why are climate scientists concerned now? Why should we be concerned now if there's always been changes in the Earth's climate? Well, we can look at the changes in the Earth's climate, right? We can study them pretty well. And we know that what's happening now, the rates at which Earth's temperature is increasing, they far exceed anything we've seen in the past, first of all, okay? And also, they are way beyond what could be explained by these natural fluctuations, okay? So they're way beyond anything that we could say, oh, it's the Milankovitch cycles, or oh, the sun's at a solar maximum, okay? It's way beyond anything that those could possibly explain. In fact, when we take into account all those other things, if we just ignore everything humans have done, the Earth, because of those other natural cycles, it would actually be headed into a period of global cooling. It should be, right? When human activity is not accounted for, all of the natural causes that we looked at should be taking us into a period of global cooling, right? That is not what we see happening, right? We can't explain it with the natural cycles because the natural cycles say things should be getting cooler right now. Of course, that is definitely not what's happening, right? It's sometimes even called global warming, although climate change is a better name for it because a lot more happens than just the Earth getting warmer. Our entire climate will change. Okay, by far, the number one, the biggest factor in the current warming of our climate that's happening. Okay, so the largest factor in the current warming is by far the massive increase in greenhouse gases in our atmosphere since the Industrial Revolution in our atmosphere. And I want you to look at this graph here, okay? So looking at this graph here, you see the highest historical CO2 level that we have on record, including those from ice cores. So you can see this goes back 400,000 years. The highest is about 300 parts per million, right? Ever. These are peaks. These are the natural cycles. Look where we are now, right? It's way beyond the natural cycles. Also, if you look, okay, roughly where did it start to peak? Very recently, okay? Why so recently? Well, it started in about the year 1850. You might know from social class what started to happen then? The Industrial Revolution, okay? What was the Industrial Revolution? Well, it led to us using lots of machines. It definitely did make our world a better place in a lot of ways, okay? But those machines, what they did is they did combustion reactions. You might remember from chemistry, combustion takes oxygen and a fuel and burns it to make, ding, 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 CO2, carbon dioxide. And carbon dioxide is a greenhouse gas, okay? So the Industrial Revolution, machines combust fuel, producing CO2, carbon dioxide, which is again, a greenhouse gas. So again, these CO2 levels are kind of off the charts since the Industrial Revolution. And we know, as we saw before, CO2, a greenhouse gas. So what does that do? It traps more solar radiation and it warms the Earth, right? This kind of shows what I was talking about before. Okay, now some people say humans have had no effect on this. It's natural cycles. So I'll show you this graph. This is a good one. Look at the black line. Okay, the black line is not up for debate. The black line is what we've seen. It's what we actually observe in the world, right? These are the global temperatures that we observe in the past about 100 years, okay? So the black line is what we actually have seen with our data, right? Bloop, bloop, bloop. And some people might say, some people try to say that, well, that's just the natural progression. Things are heating up because that's how natural cycles work. Well, when we look at just the natural factors, we say, okay, well, if that's true, let's just ignore human activity and see what would happen, right? What do the natural predictions say based on the cycles we see that aren't influenced by humans? So the things like the Milankovitch, the solar cycles, the albedos, things like that, right? Well, you would expect this green curve to be what we would follow, okay? Notice, pretty low, right? In fact, it's actually about to peak, and you can see what I mean. It's about to go back down, it looks like, kind of, if we're assuming it follows that natural cycle. If we factor into our models, we say, okay, let's take into consideration now what humans are doing. Let's consider our greenhouse gases. Let's consider our effect. Look at how much more closely it matches what we're actually seeing, right? So when people try to say that humans have no effect on this, it just happens naturally. Well, they're really not considering the data, right? They're really not looking at how closely our models reflect what we actually observe when we stop and consider, are humans maybe playing a role in this, right? In fact, 97% of climate scientists agree that not only is climate change happening, that we are causing it. 97%. Scientists really don't agree on that much to 97%. We're talking like, that's how many scientists agree that the sky is blue. So again, no doubt that we have increased CO2 rates. Just quickly, let's look at the greenhouse effect again to remind ourselves of what that means, okay? So if we have Earth, okay, here's Earth normally, here's Earth with dramatically increased greenhouse gases. So Earth has an atmosphere. Now, normally, sun comes in, right? And it gets absorbed, the Earth warms up, and then it gets emitted back to space. Okay? And sun comes in, gets warmed up, gets emitted back to space. Now, some of that does, in fact, right? Some of it does come in, okay, and get trapped by these greenhouse gases. And right, like we said, a little bit of that is a good thing. It keeps the Earth at actually kind of a nice temperature, right? What's happening now, though, okay, what seems to be happening now, though, is that way more of it, because there are so many more greenhouse gases, way more of that solar radiation is actually getting absorbed and not allowed to leave, okay, which is causing the Earth to heat up more than it can stably kind of support. That has already begun to lead to some massive changes in our climate, and it kind of will continue to do so over the next few years unless some changes are made. So again, just more radiation is trapped in our atmosphere than would normally be, which means the Earth gets warmed up more than normally would. Okay, I'll show you this quick video showing how greenhouse gases, how we can actually see the trend between greenhouse gases and the temperature of the Earth, as well as how we know that greenhouse gases are responsible for this absorbing of the extra sunlight.
Our planet's atmosphere has been warming recently, and the cause is something called greenhouse gases. But what exactly are greenhouse gases, and how do we know they cause our planet to warm up? The objects on this table are at room temperature, each more or less as warm as the objects next to it. But some things are warmer than others, like this cup of tea. Because the cup of tea is warmer, energy is flowing from the tea to the room around it, in the form of infrared radiation. By using an infrared camera, we can watch the cup of tea cool as it transfers energy to the room. Over time, it will reach the same temperature as the other objects around it. In science, this transfer of energy is what we call heat. Now, let's step back and imagine our planet. Our sun is continually transferring some of its energy to our planet. Much of that energy travels right through Earth's atmosphere and reaches the surface, where it is absorbed and re-emitted into the atmosphere in longer infrared wavelengths. If all of that energy passed through the atmosphere directly into space, our planet would be quite cold, on average around -18 degrees Celsius. But infrared energy can interact with certain gases in the atmosphere, which are known as greenhouse gases. These gases interrupt the flow of energy escaping from Earth, holding some of that energy in the atmosphere. It is a little like throwing this towel over this heating pad. The towel interrupts the flow of heat, trapping the energy near the surface of the pad. A simple experiment will demonstrate which atmospheric gases behave in this way. Here are 4 cylinders filled with 4 atmospheric gases: nitrogen, oxygen, carbon dioxide, and methane. Notice the gases are transparent to visible light, just like the atmosphere. But in this experiment, we'll test which ones are transparent to infrared light. This heating pad emits infrared wavelengths and will simulate our planet's surface. We've sealed the ends of each cylinder with thin plastic wrap, because glass itself blocks infrared radiation, but the thin plastic doesn't. We'll start with a cylinder filled with nitrogen gas and place it between the infrared camera and the heating pad. Looking down through the cylinder, we notice that the infrared energy passes right through nitrogen without being absorbed. If we try the cylinder filled with oxygen gas, we get a similar result. But carbon dioxide is a different story. Notice how the image in the infrared camera becomes much cooler. This reveals that the carbon dioxide is absorbing some of the infrared energy given off by the heating pad before it can reach the camera. And here is methane. Methane also absorbs the infrared radiation. So, greenhouse gases, like carbon dioxide and methane, are gases that absorb energy, trapping more energy in the atmosphere. But to see if greenhouse gases actually behave this way in the atmosphere, we have to move from our tabletop experiment to the real world. The first piece of evidence comes from a satellite measuring the wavelengths of infrared energy escaping from Earth's atmosphere. Since the precise wavelengths absorbed by each greenhouse gas are known, the satellite should detect gaps at those precise wavelengths. This curved line shows what would be detected if no gases were absorbing energy. And this squiggly line shows the real measurements from the satellite. The difference between the curved line and the squiggly line reveals the energy being absorbed by greenhouse gases. These wavelengths here are missing because of carbon dioxide, and this dip is caused by methane. And these gaps show wavelengths absorbed by water vapor and ozone, two other important greenhouse gases. This is the energy that doesn't escape through the atmosphere and remains behind to warm the planet. Next, we have to see if a change in the amount of greenhouse gas in the atmosphere causes a rise in global temperature by looking at things over time. Here is a chart that shows a 40% rise of atmospheric carbon dioxide over the last 60 years. And here is a chart that shows global temperature over the same period. The average surface temperature of our planet has been rising at the same time as we've been putting more and more greenhouse gases, like carbon dioxide, into the atmosphere. So, given our little experiment and the evidence from real-world measurements, it is very difficult to ignore the fact that greenhouse gases are causing our planet's climates to change. And once we realize this, we have to ask ourselves, what are we doing about it?
That wraps up this week's topic, all about the Earth's changing climate and how glaciation has shaped the surface of the Earth. So the big stuff you should be able to answer now, okay, is why are scientists actually concerned about the current changes in our climate, right? Why, if the Earth's climate has always been changing, why are we worried about it right now? Okay, what kind of climate trend would the Earth be heading into if not for human influence? So if we ignore everything caused by humans, what does the natural stuff say we should be doing? And bonus question, does that agree with what we're actually seeing? So can we ignore human stuff and still get an accurate picture of the climate trends we see? Okay, and what do scientists agree is the cause of the current changes in our climate? Okay, that wraps up not only topic 4, but this week's worth of stuff in Science 20. So if you're looking for practice with this stuff, try the topic 4 section of the practice assignment for the week. If you're feeling good about that and you've asked all your questions you want to ask me, you've come to Flex or whatever, okay, then go ahead and try this week's summative Google form assessment. Okay, have a great weekend.